Hello everyone, I'm Avi Steiner, a postdoctoral associate in the Department of Mathematics. Today I'll be telling you about a project I call Your Subject in the Wild. How do you engage students when there's no obvious, immediate, real-world application? The traditional answer is to introduce application problems, problems which apply course concepts to real-life situations. However, when presented with an application problem in the artificial classroom environment, students often feel that it's unmotivated, or that it's not really what's done in the real world. To address these issues, the traditional answer is to bring in guest speakers. But this has its own difficulties. There's often a disconnect between what I think the students will be interested in and what they actually are interested in. Plus, something which is interesting to the students this year might not be even a year or two down the line. My solution is to have each student find people from outside careers on their own. For instance, a student taking a linear algebra course could talk to an animator. This deceptively small change to the guest speakers paradigm can have a huge positive effect on student engagement. It allows each student to meet with people who work in careers that student actually finds interesting, rather than with someone who I, as the teacher, think they'll find interesting. By allowing students to gain such insight on their own, they will be more motivated to engage in the learning activities of the course itself. To make things concrete, I'm going to phrase everything from now on using the linear algebra example. By the end of this project, students will be able to identify at least one career other than mathematician which uses linear algebra, explain using a specific example why linear algebra is necessary for that career, and with explicit reference to topics covered in this course, distinguish the pure linear algebra concepts and ideas necessary for the example from the applied ones. The project consists of 3 phases: search, interview, and summarize. In the search phase, students will search for someone outside of mathematics who regularly uses linear algebra in the course of their work. This can be difficult for some students, so they may need some guidance. One idea is to have them search for linear algebra on job search websites. It's pretty likely that if a company is looking for someone with experience in linear algebra, they already have somebody who uses it too. It'll at least tell you that similar companies might also have someone. Another idea is to put together a small list of sample careers. An example of such a list can be found at weuseMath.org. When you click on one of the careers there, it'll tell you whether or not it uses linear algebra. A bunch of them do. In the interview phase, students will ask their interviewee questions based on a rubric, which you must provide, and in the summarize phase, the students will summarize, in their own words, what they learned from the interview. For both of these phases, you'll need to provide a rubric. When I ran this project, the rubric had 3 metrics. First is background and motivation. Each student should have their interviewee focused on a single example. For instance, an animator being interviewed by a linear algebra student might discuss texturing of 3D shapes. Why is this example important to the interviewee? Next is necessity of linear algebra. Why is linear algebra necessary to the example? Last is relationship to linear algebra. Which major course topics are used in the example? What terms/concepts used in the example are not discussed in the course? How does linear algebra contribute to the example? What parts doesn't it contribute to? One goal here is for the students to be able to separate the pure linear algebra concepts from the applied. For instance, texturing 3D shapes using pure linear algebra concepts, such as subspaces and linear transformations, but it also uses things from outside of linear algebra, such as calculus and physics. I've phrased the project entirely for use in a linear algebra course. However, with small adjustments, it can be used in many more contexts, even outside of math. For instance, a geology student could interview a mine geologist, and an oceanography student could interview a fisheries scientist. In each of these courses, students may find it difficult to really internalize how they can be used in the real world. By allowing them the freedom to discover the real-world applications on their own, the students will be more likely to stay motivated throughout the course and ultimately learn the material better.